A muscle fiber or a muscle cell consists of bundles of myofibrils. Myofibrils are the contractile organelles found in cytoplasm of muscle cells. They're long and tube-like and have light and dark bands along the length. The striations are created and aligned by myofibrils within the sarcolemma. Myofibrils are protein strands. There's two types, actin and myosin. The myosin filament is a thick protein and consists of multiple myosin heads. Actin is a thin protein and it's anchored to the Z disc in the I band. A muscle fiber or a muscle cell consists of bundles of myofibrils. Myofibrils are the contractile organelles found in cytoplasm of muscle cells. They're long and tube-like and have light and dark bands along the length. The striations are created by perfectly aligned myofibrils within the sarcolemma. Myofibrils also consist of sarcomeres, which are the tiny contractile units made up of actin and myosin. Myofilaments are the protein strands which contain actin and myosin. Myosin is the thick protein filament and has multiple myosin heads, and actin is the thin protein filament and it's anchored to the Z disc in the I band, and they don't overlap ends of the myosin fibers. They also don't extend into the middle of the H zone, which is also the A band. Light bands, also known as I bands, contain only actin filaments, and they're parts of two adjacent sarcomeres. Z discs are the darker area in the middle of the I band, and they connect actin filaments. Dark bands, also known as A bands, consist of actin and myosin filaments. Myosin filaments extend the entire length of the A band, and they have a lighter central area. The H zone has no actin filaments and is located there. The H zone also has a central line called the M line. The M line protein rods connect myosin filaments. Sarcoplasmic reticulum is smooth endoplasmic reticulum that surrounds every myofibril, and it stores the calcium needed for contraction. Also, the sarcolemma surrounds the muscle cell membrane. It encloses many myofibrils, many nuclei, sarcoplasmic reticulum, and mitochondria.
Is that it? Yeah. A motor unit, a motor neuron, and all the muscles it stimulates sends a nervous impulse which reaches the muscle through the neuromuscular junction. The neuromuscular junction is where the axonal ending of the motor neuron meets the sarcolemma, which is the cell membrane of a muscle cell, which is a myofiber. After passing through the sarcolemma of a myofiber, the neurotransmitter stimulates the sarcoplasmic reticulum to release calcium ions.
The calcium, which is sent from the sarcoplasmic reticulum to the myofibrils, other organelles in the myofiber bind to the actin filaments and change their shape, exposing myosin binding sites. Both myosin and actin are myofilaments, which are proteins within myofibrils. The myosin heads can now bind to the actin filaments via the myosin binding sites and drag the actin filaments closer and closer, shrinking the H zone and moving the Z discs closer together. This shortens the sarcomeres, the contractile units that measure from Z disc to Z disc, therefore shortening the myofibrils and the myofibers, which make the muscle contract. When the myosin heads attach to the myosin binding sites on the actin filaments, cross bridges are formed.